Okay, so in this part we will study about some properties of hyperbola. Okay, so if I am talking about hyperbola, I am talking about horizontal hyperbola and its conjugate. Okay, its conjugate means just change 1 with minus 1 and you will get its conjugate hyperbola. Okay, now look at the first point. The first point is like you know that suppose this is x-axis and y-axis, so you know that there will be hyperbola. So hyperbola means this is your horizontal hyperbola, this is your vertical hyperbola means conjugate hyperbola, and it is its conjugate. Okay, so this thing will be the foci, this thing will be the foci and foci. Okay, so what I want to convey is, if you will try to connect the foci, okay, suppose that you have connected the foci. Okay, so this will be concyclic. Concyclic means opposite angle sum will end up being 180 degree. Also, this thing will create a square. Okay, so this blue quadrilateral is a square. So I'll write down this point. The foci of a hyperbola and its conjugate are concyclic. Okay, so with the help of this idea you can find out the angle between these straight lines. Okay, concyclic and form the vertices of a square. Okay, so this is also forming an square. For angle you can take help of concyclicity, means these points will lie on a circle. Okay, now we have another property. We have relationship between eccentricity of hyperbola and we have relationship between eccentricity of its conjugate hyperbola. Okay, so look at this. If E1 and E2 are eccentricities of hyperbola and its conjugate, then you have to tell me the relationship. Okay, now look at this. You know that I am talking about hyperbola. So hyperbola means horizontal hyperbola. Horizontal hyperbola is derived from horizontal ellipse. In horizontal ellipse we have a as bigger, so a will go inside, b will stay outside. But we are not talking to ellipse, we are talking to hyperbola. So in hyperbola we have minus of b square, so replace b square with minus b square. Okay, so this is your hyperbola and I'll be using eccentricity as E1 for hyperbola. Okay, now I'll go with conjugate hyperbola. Okay, so you know that again conjugate hyperbola is derived from vertical ellipse. Okay, so 1 minus e square for sure, and in vertical ellipse b is bigger, b square is bigger, so b will go inside. But you are talking to hyperbola, not ellipse, so you have to replace b square with minus of b square. and here eccentricity will be different, so I'll be taking eccentricity 2. Okay, now you got both the relationships, and you know that A and B will remain the same. Okay, because we are talking to its conjugate, means we are changing 1 with -1. We are not changing A, we are not changing B. Now observe these two equations and try to find out relationship between A and B. So do you think we can go with addition, subtraction, multiplication, division? According to me, if I'll go with multiplication, that would be a better idea. Why? Try to understand. So in this side we have minus of b square and we have a square. So on LHS we will have minus of a square b square. Now observe RHS. A square minus b square. Yes, same thing. A square b square. 1 minus e1 square, 1 minus e2 square, correct? I don't know what will happen to other things, but this minus will be neutralized, this thing and this thing will be neutralized, and we will be left with 1. Okay, so 1 into 1 1 minus e2 square minus e1 square plus e1 square e2 square. This one vanish. Can I ask e1 e2 to come this side? So e1 square plus e2 square is equal to e1 square e2 square. Okay, so this is the relationship between eccentricities of hyperbola and its conjugate hyperbola. Okay, if you can memorize, please memorize, otherwise we will find some different ways. Okay, but you can derive this thing as well. Okay, so if you are not able to memorize na, then try to simplify the same thing twice or thrice. Okay, so that you can have good command over the approach. If required, you can like follow these steps and you will get the relationship done. I hope till this part you guys are comfortable.